questions 5 through 7 on the 2006 Grade 12 Euclid Math Contest. If A is chosen randomly from the set 1, 2, 3, 4, 5, and B is chosen randomly from the set 6, 7, 8, what is the probability that A to the power of B is an even number? 1, 2, 3, 4, 5, that's set 1. And set 2 is 6, 7, and 8. So let's just be complete since there's not that many choices. We can do each of these. The first one is 1 to the power of 6, then 1 to the power of 7, then 1 to the power of 8. Next one, 2 to the power of 6, 2 to the power of 7, 2 to the power of 8. Right? 3 to the power of 6, 3 to the power of 7, 3 to the power of 8. 4 to the power of 6, 4 to the power of 7, 4 to the power of 8. And finally, 5 to the power of 6, 5 to the power of 7, and 5 to the power of 8. So we've got 15. And like any probability question, it's going to be a fraction, the numerator over the denominator, and the denominator is the total number. Total number is 15, as we just wrote, well, as I wrote. And the numerator is going to be the specific condition. And in our question, the specific condition is that we want it to be even. All right, let's figure out what these all equal. 1 to the power of anything is just going to be 1, right? So these are all odd. Odd, odd, odd. 2 to the power of anything is going to be even, I think. 64, 128, and 256. 3 to the power, let's see here, 729, 2187, and 6561. 4 to the power of 64096. Let's see here, 16384 and 65536. And then 5 to the powers, we got 15625, 78125, and finally the biggest number, 390,625. All right, so let's circle our even ones. This one, and this one, and these 3. The rest are all odd. So that's 6 that goes into our numerator. And there you go, that's the probability. Most likely they're going to reduce it to lowest terms, so divide top and bottom by 3, and that'll give you 2 over 5. And that is the answer to the first part of number 5. A bag contains some blue and some green hats. On each turn, Julia removes one hat without looking, with each hat in the bag being equally likely to be chosen. If it is green, she adds a blue hat into the bag from her supply of extra hats. If it is blue, she adds a green hat to the bag. The bag initially contains 4 blue hats and 2 green hats. What is the probability that the bag again contains 4 blue hats and 2 green hats after 2 turns? So first, let's just talk about this question in terms of what is the rule or the process. We start with 4 blue and 2 green. If you take away a green, you will be left, of course, with 4 blue and 1 green. But then the rule is that you have to add a blue hat, right? Just read the question. Julia removes a hat. If it is green, she adds a blue. So if you add the blue, your scenario becomes like this. 5 blue and 1 green. All right? The other scenario, of course, is you start off with the 4 blue and 2 green, and instead of removing green this time, we will remove blue. If you remove a blue hat, initially you drop down to 3 blue and 2 green, but then the rule states if it is blue, she adds a green. So we have to add a green. So that makes us have 3 blue and 3 green. Okay, this is what's happening. Now, they want you to figure out the probability that after 2 turns, you again are back to your original, which is 4 blue and 2 green. All right, so we got 2 turns, right? So 2 turns basically means that we have 4 scenarios, and I'll call them turn 1 and turn 2. And there's really only 4 possible ways, right? The first turn, you could remove a blue, and the second turn, remove a blue. The other scenario would be remove a blue and then remove a green. The other scenario would be remove green and then remove blue. And the final scenario would be remove green and remove green. That's the only possible scenarios for what you will remove. So let's figure out what this looks like for each of these. All right, so here we go with the first one. Initially, you're starting off, of course, with the 4 blue and the 2 green. So you first remove the blue. So that drops me down to 3 blue and 2 green. But then the rule is that I have to add a green. And if I do that, it brings me up to 3 green. Now I turn 2, have to again remove the blue. So now I'm down to 2 blues. But then I have to add a green since I removed the blue. So this is what I end up with. I end up with 2 blues and 4 greens. Is this the same as what I started with? And the answer is no. So I'll put an X there. This is not what I want. Okay, let's go for the next one. Start off with the same, but our first turn, we're going to remove a blue. So we drop down to 3 blue and 2 green, but then the rule states that I have to add a green. So that's where I am after turn 1. Turn 2, you remove a green. So I remove 1 green, but then the rule says I have to add a blue. So this is what I end up with. Is my final scenario or final result the same as the initial? And the answer is yes. So that's a check mark. That is the scenario that I want. So you get the hang of this. So next one, start off again with the 4 blue and the 2 green. Remove G this time, which is green. So that's what happens when I remove a green hat, but I have to add a blue according to my rule. And then the turn 2, remove a blue. So that means it drops me down to 4 blue, but I have to add a green according to my rule. So I'm back to 4 blue and 2 green. It matches the initial. So that's a check mark also. And then finally, the last one, same thing, start off with 4 blue, 2 green, remove a green, so that means I'm down to 1 green, but then we add a blue. And then again I remove a green, so that green is gone, and I'm just down to just the blue hats, but then I have to add a blue hat. So in the very end, I end up with 6 blue hats and 0 green. And is that the same as the initial scenario? Well, no. So that's a negative, or X, whatever. So what's my probability? Well, I had 4 scenarios, and 2 of them are a check mark. So my probability is 2 over 4, which is a half. Yes or no? You tell me, is this correct? The answer is a big no. That is not correct. Why? Why is it not correct? I mean, you follow this, no problem, makes sense. Why would this not be correct? The reason is because if you look at these 4 scenarios, each of them does not have an equal probability. All right, because we're not starting with an equal number of blue and green. We have 4 blue and 2 green. So the scenarios vary with regard to the probability of each scenario occurring. So this is a common mistake that's made probably on this question. Unfortunately, it's wrong. So now let's concentrate on what is the probability, the correct system. Well, let's look at just our question marks, our checks, because those are the ones that we're interested in. For the first turn, we took a blue hat and removed that. What is the probability of that? Well, we started with 4 and 2. So there was 6. Out of those 6, we want to remove a blue. So there's 4 out of 6 chance of removing a blue from those 6 hats. Okay, that's the probability of that first turn. Now we are going to remove a green hat. From where? From this scenario, right? This is where turn 2 begins. From that scenario, what's the probability of removing a green hat? Well, it's 3 out of 6. You have 3 chances of removing a green hat from the 6. To get the total probability of this scenario, you have to multiply those two. So 4 over 6 times 3 over 6. And that is 12 over 36. And in the lowest terms, that's 1/3. So you see how that is 1/3. It's not 1/4 like you probably may have thought. I'm not saying you did, but maybe somebody did. So that is very important to understand for this question. All right, let's turn our attention to the next one. The next one, you remove a green. What's the probability of removing a green from that? Well, it's 2 out of 6, right? 2 greens are possible as your picks. And then for the next turn, you're going to remove a blue, but a blue from where? A blue from this scenario. What's the probability of removing a blue from there? Well, it's 5 over 6. To get the overall probability for that turn or that scenario, those 2 turns, I should say, you have to multiply them. So 2 over 6 times 5 over 6. And that is 10 over 36. In lowest terms, 5 over 18? Yeah, 5 over 18. Now, to get the total probability for this question, you have to add these. So 1/3 plus 5 over 18. And top and bottom by 6, so that would be 6 plus 5 over 18. And that is equal to 11 over 18. That is the correct probability for this question. Suppose that for some angles x and y, sine x squared plus cos y squared is equal to 3 over 2a, and cos x squared plus sine y squared is equal to 1 over 2a squared. Determine the possible values of a. So, this question, it is crucial to recall that sine x squared plus cos x squared is equal to 1. That is definitely something you will need to have remembered. Otherwise, I don't know how you'd be able to solve this question. All right, so knowing that, let's proceed. Our first equation that they give us is sine x squared plus, be careful, cos of y squared is equal to 3 over 2a. And our second equation that they provide is cos of x squared plus the sine of y squared is equal to 1/2 a squared. Now, I think you will quickly be able to deduce that these two equations must be added. All right, so adding 1 plus 2 gives us, I'm going to group them, sine x squared plus cos x squared, and then sine of y squared plus cos of y squared, like that. And then the right side is 3 over 2a plus 1 over 2a squared. All right, well, that's 1, and that's 1. So you see how handy that comes in? And this becomes 3 over 2a. It's the same. Nothing really changes on this side. Now, this is 1 plus 1 is 2. So I'm going to multiply through everything by 2. Get rid of these fractions. So 2 times 2. So that's going to be 4. And then that would be 3a plus a squared. All right? So let's put everything on one side. And if we do, we get a squared plus 3a minus 4 is equal to 0. And I believe this factors So we get A, 4, and 1 minus plus. Yeah, I think. Actually, no, I had it reversed. Minus plus is not right. Plus minus. All right, don't make that mistake. Yeah, that will be a proper factor of that quadratic. All right, so that tells me that A is either minus 4 or 1. Okay, as always on these kinds of exams, we got to verify, especially when there's sines and coses or logs. That's another one, to ensure that the values that we get are actually legitimate. Well, when you do that, you'll find out that A equals negative 4 is not possible. You say, well, why? What's the story here? Well, the reason is because if A is equal to negative 4, then equation number 1 would become sine of x squared plus the cos of y squared is equal to negative 4 times 3, which is negative 12 divided by 2, negative 6. And obviously that's not possible. There's no way you can get negative 6. The largest value for sine is 1, right? The largest value for cos is 1. So the largest value for the square would be 1 and 1, so it'd be 2. And notice this is x and y. Don't confuse it with x and x, because you might think, well, that equals 1. This does not equal 1 because this is x and y. But regardless, it cannot be 6. All right? So therefore, the only legitimate value of A for this question is the 1. A equals 1. Survivors on a desert island find a piece of plywood, ABC, in the shape of an equilateral triangle with sides of length 2 meters. To shelter their goat from the sun, they placed edge BC on the ground. Lift corner A and put in a vertical post PA, which is h meters long above the ground. When the sun is directly overhead, the shaded triangle PBC on the ground directly underneath the plywood is an isosceles triangle with largest angle BPC equal to 120. Determine the value of h to the nearest centimeter. All right. Well, a few ways of doing this question. I'll just take it exactly step by step the way they are discussing it in the question stem. So they first tell you ABC, right? They give you the length of the sides is 2. So that's very helpful. It immediately lets us know that AB is 2, BC is 2, and AC is 2. If we need all these lengths, we don't know, but at least we know them. And then they bring in this H, and we have to actually determine the value of that. And immediately, since they've put a right triangle there, it makes me think that's got to be Pythagorean theorem. Okay, so immediately, without even moving forward, I can tell that h squared plus pb squared is equal to ab squared, which is 2 squared. All right, so I have to concentrate on getting the value for pb. If I can get the value for pb, I'm done. I can figure out h. So that is where this whole isosceles triangle comes in. The way they've drawn PBC, of course, it's from an angle, right? So it's hard to tell, is that isosceles? If it is, what are the two equal sides? Are the two equal sides PB and BC? Right? It's a little confusing. So what I'm going to do is draw it the way it will look like if you were looking at it head on. Exactly the way an isosceles triangle should look. And that will make it clear. So this is my isosceles triangle, and P is here, C is here, and B is here. Now you might say, well, how do you know that? How do you know that PC and PB are the two equal sides? In the diagram here, it doesn't look that way. Well, they give you the clue. They tell you that the largest angle is BPC. BPC. This is the largest angle. They basically tell you that in the question. They are giving you this information, not me. So since that's the largest angle, these must be the two equal angles. Basically, like any isosceles triangle. And I don't even know if you... Well, actually, I think you will need to know the angle. 2x will therefore plus 120 is equal to 180, right? Sum of the angles of a triangle. So 2x is equal to 60, and therefore x is 30. So x is equal to 30. Now what I'm going to do is drop a perpendicular from P down to the base like this. All right? Like that. And if I do that, you will be able to understand that this angle is 60. For a couple of reasons, actually. First, because that perpendicular cuts the 120 in half. The other reason is because since this was 30, the other angle is 90 minus 30. So without a doubt, that's 60 degrees. Well, there you go. Again, for the 100th time on these math contests, you've got a 30, 60, 90 triangle. And like all 30, 60, 90 triangles, the ratio of the sides is 1 for this side, opposite 30 degrees, root 3 for this side, opposite 60 degrees, and 2 for the hypotenuse, the ratio of the sides. Well, do we know the length of any of these sides? We do. The length of BC, right here, is 2. So that means this BC is 2. Now that red line that I dropped as a perpendicular, it cuts BC in half. So therefore this is 1 and this is 1. All right? So now what we are interested in is PB. Well, we can figure out PB using the fact that we know the ratio of the sides. So PB over 1, this 1 right here, is equal to the ratio of the sides, which is 2 over root 3. So there you go. PB is basically 2 over root 3. All right. Here we go. We got PB. So h squared plus PB squared, which would be 4 over 3, is equal to 4. Correct? So h squared is going to be 4 minus 4 over 3. So h squared looks like, let's see here, 12 minus 4, which is 8, 8 over 3. Now don't forget to take the square root. That's h squared. H is going to be the square root of this. So the square root of 8 over 3. All right? Now, they want you to figure out the value to the nearest centimeter, so I guess we have to figure out the actual decimal or numerical value. If you take the square root of 8 over 3, it gives you 1.633, but this is in meters, remember. So if you want the height in centimeters, multiply that by 100, and you'll get 163 centimeters. And that is the answer to this question. The sequence 2, 5, 10, 50, 500 is formed so that each term after the second is the product of the previous two terms. The 15th term ends with exactly k zeros. What is the value of k? So 2, 5, 10, 50, and 500, those are the first 5 terms. Now we have to figure out the 15th term, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'll just label those. Now we have to apply this rule that each term is the product of the previous two terms. But instead of writing all these numbers out, the numbers are going to get very, very big, right? I'm just going to keep it simple. All right? How am I going to keep it simple? I'm going to let A equal 2 and B equal 5. All right? Just keep it simple like that, and it won't get confusing. The next term is just AB. The next term is AB squared. The next term is a squared b third. You see what's happening? Keeping it simple. Let's continue in that way. to figure out all the other ones. A to the power of 3, B to the power of 5, right? All we're doing is just using the rule that each term is the product of the previous two. A8, B13, and so on, right? A13, B21, A21, B34, right? Just following the simple rule that each term is the product of the previous two. The ninth would be, we're up to 12 now. B89. 13th will be A89 times B144. And just a couple more. A144, B233, and finally A233 and B377. So the 15th term is this guy right here. Now we have to figure out how many zeros are at the end of that number. All right. The 15th term is A to the power of 233 times B to the power of 377. Now, my A, if you remember, is 2. So this is 2 to the power of 233, and my B is 5, 5 to the power of 377. Okay, at this point you think, well, that doesn't help me at all. I mean, I've got these gigantic numbers, and I'm certainly not going to be able to use a calculator because my calculator doesn't go that high. But not to worry. If we can make the exponents the same, we can combine them. And we can, 233, but the 5, I'll break it up into 233, and 377 minus 233, which is what, 144? Yeah. So there you go. Now the exponents are the same, so those bases can be combined as follows. 2 times 5, all to the power of 233, times 5 to the power of 144. All right, hope that makes sense. Now this 5 to the power of 144, I'll just put out front like this. That's some big number, whatever it is, it's not important. But what is important is this guy right here. 2 times 5 is 10. So we have 10 to the power of 233. So what that means is that you've got this big number, 145 to the power of 144, times 10 to the power of 233, which is essentially 0, 0, 0, dot, 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 0, 0, 0. And how many zeros do we have? 233 zeros. So if you rearrange it, you'll be able to figure out how many zeros there are without having to calculate this big long number. So they basically are saying that exactly k zeros is what this term ends in. What is the value of k? Well, k is equal to 233. Suppose that A, B, C are 3 consecutive terms in an arithmetic sequence. Prove that a squared minus bc, b squared minus ac, and c squared minus ab are also 3 consecutive terms in an arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. For example, 357 is an arithmetic sequence with 3 terms. Now, an arithmetic sequence is of the form a plus d, a plus 2d, a plus 3d, a plus 4d, and so on, right? You get the point. Like that. This is what is known as an arithmetic sequence. There's geometric sequence also, but we don't need to worry about that. So what I have noticed is that they've given me letters A, B, and C. They're telling me that A, B, and C are 3 consecutive terms. So without getting overly complicated, I'll just let those 3 terms be A plus D, and A plus 2D, right? Perfectly fine. And these are indeed consecutive terms of an arithmetic sequence. Now, there's one condition that you can actually figure out yourself you don't even need to memorize it. That is that if you take the second term and subtract from it the first term, a plus d minus a, it will be the same as if you take the third term and subtract the second term. So that would be a plus 2d minus a plus d. Now watch what happens. On the left side, you just get d. On the right side, you get a plus 2d minus a minus d, and that just leaves you with d. D equals d. Right? That's a fundamental principle of arithmetic sequences. So that basically means for me in this question that if you apply it using our letters, that b minus a, right, the second term minus the first term, is equal to c minus b, the third term minus the second term. Okay? Hope that makes sense, right? So that's how we are going to proceed. We have to show the exact same thing for the three that they have given us. And the three that they have given us are a squared minus bc, b squared minus ac, and c squared minus ab. All right? First, we'll figure out what each of these are in terms of our a and a plus 2d assignment, and then we will apply this rule. Okay? So here we go. So first and foremost, a squared minus bc. So that means a is just a. B was a plus d, remember? And then c was a plus 2d. So this becomes a squared minus, let's just keep it in brackets, a squared plus 2ad plus ad plus 2d squared. And this becomes a squared minus 3ad minus 2d squared. And that looks like minus 3ad minus 2d squared. Okay? That's about as far as we can go there. All right, now let's turn our attention to the next guy, b squared minus ac, and that is a plus d all squared minus a, and then c was a plus 2d. So this is going to be a squared plus 2ad plus d squared minus a squared minus 2ad, and that looks like just d squared. Okay, let's go to the last one. That's a plus 2d all squared minus a times b, which is a plus d. And this is going to be a squared plus 4ad plus 4d squared minus a squared minus ad. Correct? So let's see, anything cancel? Yeah, a squareds cancel, and you're just left with 3ad plus 4d. All right, great. So this is my first one, this is my second one, this is my third one. Now remember, as I showed you before, in order to prove that this is an arithmetic sequence, we have to show that the second term subtract the first term is equal to the third term subtract the second term. So that basically means that d squared minus the first term, which is minus 3ad minus 2d squared, has to be equal to the third term, 3ad plus 4d, minus the second term. Okay, if this is equal, then we have proven that they are consecutive terms of an arithmetic sequence, these three guys. 1, 2, and 3. So there we go. Let's figure this out now. So here was our second and first. We have to subtract that. And here's our third and second term. Subtract those. And those should be equal. Well, we figured them out in terms of the A and D substitutions. And this is what we got. So let's figure out the left side first. D squared plus 3AD plus 2D squared. And that just looks like 3AD plus 3D squared. Now let's turn our attention to the right side. And this looks like, oh, I forgot a D squared here. Oh, don't make that mistake. All right, no problem. I caught it. 3AD plus 4D minus D squared. 3AD plus 3D squared. And there you go. Left side equals the right side. Left side equals the right side. And therefore, this proves that those are consecutive terms of an arithmetic sequence. A squared minus BC, B squared minus AC, and C squared minus AB are indeed consecutive terms of an arithmetic sequence. So, the proof is complete.